Okay, so we're going over 6.6. My camera froze, and instead of deleting everything, I'm just going to run through it real quick. So all transformations result in an image with congruent corresponding angles. Not just dilations, not just rigid transformations, all transformations. Okay, only rigid transformations result in an image with preserving distance, with congruent angles and sides, as are congruent shapes. Okay, congruent images. Only dilations result in an image with proportional sides. Okay, not congruent sides. That's the proportionality is congruent, or the proportionality is proportional to, is set to the scale factor. Okay, so you'll see how that is not true here. Okay, so it's the right sequence of transformations that would land this image on top of this image. Right, this is the second transformation. If they were similar. Okay, so the way I determine this is like the H and the K are on top of each other, but opposite slopes. Right, so that would mean that this would have to reflect to reorient this correctly. Right, if they were a rotation, the H and the K would be flip-flopped. Okay, so this, in order to be oriented this way, it'd have to be a reflection. Okay, but if I look at the change in X and the change in Y for these, like my change in X for H and I, right, my change in X here, 1, 2, 3, 4, is 4, and my change in Y here is 1, so my change in X, my slope, is 1/4. Same thing with here. It's change in X, change in Y, or K, J, is 1/4. Okay, if I go over here, my change in X, and it's negative 1/4 technically, but I'm only really looking at absolute values because of the reflection. Okay, but my change in X here, my change in I, and my slope here for its corresponding part, right, is it's 1, 2, 3, 4, 5. It's a 1/5. Same thing here. It's 1/5. Okay, so it got bigger, right, by some factor, by like a factor of, one, by some factor, right? So I would expect this to grow as well, right, from here to here, to grow as well, right? So this started off as a change of 3/1, right? It went down 3/1, but again, I'm just looking at absolute value, the magnitude of how much changed, and this one changed again. It went down 3/1, so I would expect this to be bigger than 3/1 because this one, this got bigger too, like actually got smaller slope, but the number got bigger, right? So, but it stayed the same, right? This is still a change of 3/1, right? 3/1. So if this was a proportional change, it would be proportional in both the X and Y direction, and this way, and the X and Y direction this way, but it's not, right? These are the same, right? These are different, right? These values changed, right? But these values did not change. So these are not similar, right? They didn't change proportion, and that's what this says right here. It just says the slope didn't change. Okay. All right. So now we have these ones here. We have a sequence of transformations. Show whether these are similar, right? So it looks like to me that this is a reflection, or a rotation, some way. Okay. So, and probably a dilation as well. What is a dilation? Maybe we'll have to see if they're similar, right? So I'm gonna, just because if I were to rotate this way, it would put R here, S here, and Q up higher, right? Maybe I could just put like a little guy right here. We're using some patty paper, right? And if I rotated this like that, it would reorient it like that way. So a rotation of 90 degrees clockwise would do the trick, right? So I'm gonna go Q, R, S. Q is -5 comma 1. R is negative 4, comma 3. And S is 0, comma 2. Okay, and if the coordinate comparison for a translation or a rotation clockwise is y negative x. It's going to push it that way, right? So I'm going to take my y's, my x's, and I'm going to flop them. The y's don't change value, okay, but they become my x's, and my x's swap signs and become my y's. So it'll be 5, 4, and 0. Okay, so my q value becomes 1 and 5. 1 and 5. This is my new q prime. And then I have my my r value is 3 and 4. 3 and 4 is my r value, r prime. And then my s value is now 2 and 0. 2 and 0. So this is my s prime. Alright, so I'm going to go ahead and draw this guy like this. I kind of missed it a little there, but that's okay. Alright, and then this is my s prime. Okay, and now that is my after the rotation. So it looks like, I'm just going to look at right here. I'm presuming that this is my point of dilation. Let me see if that checks with chart. Alright, so if I go here to here, that looks good. Go here to here, my R to R. That looks good. And then my S to S. That looks good. All right, so it looks like my O is my point of dilation. So that means that if I'm just going to use my S value to figure out my scale factor. So my S value, my scale factor, sorry, my X value for point S. My scale factor is going to be my S sub X, my S double prime sub X divided by my S prime sub X. So this is my X value for the S double prime, which is the after the transformation, the dilation. This is my S prime. Maybe I can my X value, S prime sub X, for my X value for S prime before the transformation. All right, so this is going to be 3 equals 3 divided by 2. So my scale factor is 3/2. Right, so I could check that. Here it's 2, right? So my Q value, that's bad. Right, so my R value, let's check the Y direction. Let's double check that. Y is 6. My R value for Y is 6. My after, so 6 divided by my R value before, my Y value for R before is 4, so 6 divided by 4 is 3/2. Right, so my scale factor is 3/2. So my sequence of transformations for this are going to be, my first one is I could have done it either way, right? But I'm going to do my my rotation first, right? So it's going to be X comma Y, and it's going to be Y comma negative X, and then my dilation is going to be X comma Y, and it's going to be 3/2 X comma 3/2 Y. Okay, and there you go. And are they similar? Yes, they're similar by a scale factor of 3/2. All right, so now we go. Explain your reason for number 6. See table above. Yeah, so there you go. Scale factor equals 3/2. And yeah, I'll just do this. There we go. That's why. That is why. Okay, so, and then here we go. My next one is write a sequence of transformations that would make A, B, C onto A prime, C prime, D prime. All right, so so this is our our second transformation, and this is my P prime, right? So my C's up, my B's down, and my A's are opposite. So this is a reflection of some sort. This is a reflection across the x-axis, all right? Oh, sorry, y-axis. So a reflection across the x-axis happened. So this is a x comma y. Well, my first one would be x comma y, and then the reflection across the y-axis is negative x comma y. Right. So let's do that and see where it lands. Right. So A, B, C. A is 5 and negative 4. B is 2 and negative 6. And C is 3 and negative 1. Okay, now we'll reflect it, make it purple. All right, so it's going to be negative x comma y. So these all turn negative, negative 5, negative 2, negative 3. Y's stay the same, negative 4, negative 6, negative 1. All right, so now I'll reflect those. Negative 5, negative 5, negative 4. This is A prime. Okay, and then I'm going to have negative 2, negative 6, negative 2, negative 6, negative 2, negative 6, B prime. And then I'm going to have C is negative 3, negative 3, negative 1, negative 1. That's C prime. All right, connect the dots here. Negative 3, negative 1, negative 2, negative. This is a wrong spot. My B spot's negative 2. Negative 2, negative 6, negative 2, negative 6. Here we go. Let's B prime. All right, well, it looks like my C spot is 1, 1, 2, 3. So this is 1 and 3. My A spot is 1 and 1, 2, 4, 5 and 4. It is 1 and 2. 1 and 2. Okay. This is 1 and 2. I miscounted. This is 1 and 2 up. Okay, and then my B is 1 and 2 up. Okay, so my second one is a translation. X comma y, and it's a translation of my X was plus 1, my Y was plus 2. Right, so are they similar? Yeah, I would say that they're congruent. Maybe the answer is no. They are congruent. I'm gonna say no, because similar is not congruent. No, I'm gonna say they are congruent because they underwent. They underwent 2 rigid transformations. Okay, so there you go. Hopefully that helps. Okay, so this underwent a reflection and then a translation up. Okay, no dilations were made. So they are congruent, not just similar. Okay, so I hope that you got something out of this, and I'll be posting this time now.